Welcome everyone to the WERA 103 presentation today. We're pleased to have Dr. Dan Sullivan from Oregon State University giving our presentation today. He'll be speaking on predicting plant available nitrogen provided by organic fertilizers in cover crops using an online calculator. My name's Rob Mickelson with the International Plant Nutrition Institute, and I'll be host of the presentation today. Let me briefly introduce Dr. Sullivan. Dr. Sullivan received his master's and bachelor's degree from Oregon State University, and then his PhD from Kansas State University. Then after several professional jobs, he made his way back as a professor at Oregon State University, where he's worked for over 20 years. With that brief introduction, I'll turn the time over to Dr. Sullivan, and he'll do a little more introduction of his background and his professional interests, and then he'll jump into the meat of the discussion that we'll plan on having today. So Dan, we're glad to have you with us today, and why don't you go ahead?
All right, well, thank you, Rob. So I am an extension specialist with research responsibilities, or a soil scientist researcher with an extension program. At any rate, I'm very focused on the applied nature of nutrient management, particularly as it pertains to organic nutrient sources such as manure, municipal biosolids, compost, cover crops, and so on. So my goal is to provide the best research-based information to clientele so they can use that information to make nutrient management decisions. So the calculator that I'll explain today is part of that process. Okay, so why develop a calculator? And by the way, the calculator, as I'm speaking of it, is a spreadsheet that is available for online download. It's not a complicated piece of software. So that's one criteria, is try to make it such that people don't have too many inputs to be able to use it. So this idea was really came up when we switched from having mostly conventional farming to having more people interested in organic farming. I worked with one of my partners at Oregon State University, Nick Andrews, and Nick was reporting a lot of questions coming in about how to choose input sources to supply enough nitrogen for organically grown crops. So the goal of this little spreadsheet that I'm going to illustrate today is basically to compare different sources you might have available for organic fertilizer in terms of how much plant available nitrogen is actually in the soil is produced after application of the fertilizer. And so it's largely a economic tool that you're comparing different sources of materials in terms of their common denominator as nitrogen sources. So here's my co-author, Nick Andrews. He's really the one that recognized the need for this kind of a tool. And since we put it together, Nick has presented the calculator to audiences. This is some of Nick's handiwork here, showing that we actually got some grant support from several organizations in putting this together. Okay, so I want to back up a little bit and talk about specifically what cropping system we're in, and this will kind of give you some feel for maybe the limitations of the calculator, so that we're not trying to be all things to all people. This is created pretty much for a specific need, but as it turns out, it's probably applicable to a wider need than when we first envisioned it. So I'm on the west coast of the United States. I'm close to the coast, 50 miles away. And in particular, our climate is Mediterranean, meaning that we have plenty of rainfall during the winter and we have a dry summer. So this calculator was primarily designed for vegetable crops that are grown under irrigation in our Mediterranean climate. So we go into the spring having little or no nitrate in the soil. As the soil warms up, we get mineralization happening. We do our inputs. Then when we get to the fall, we have nitrate leaching. So one of the things we're trying to do is to get the right amount for the crop without having too much left over that will leach during the winter. So typically when we're applying or using organic fertilizers, the decisions have to be made up front. We don't have great ways to side dress organic fertilizer usually. One of the things that's not in this calculator is we have no estimates of ammonia loss and we have no estimates of nitrate leaching. It turns out that if you apply a material and you work it in right away, you minimize ammonia loss. And as I mentioned, there isn't a lot of potential for nitrate leaching during the growing season. The problem comes later in the fall. So this calculator has been targeted and validated for summer vegetable crops in Western Oregon and Western Washington. Others are using it in regions around the world and report good success, but really there's no guarantee that it's applicable in any particular situation outside of our geographic area. Okay, so this tool fits in an overall process, and I wanted to highlight where it fits. So up front, we need to know how much plant available nitrogen is needed, and usually this is a fertilizer guide, or sometimes we actually know what the crop takes up and we have some estimate of the amount of mineralization that happens in the soil in the absence of new inputs, which I'll be referring to as baseline mineralization. We also want to know about nitrogen that is in irrigation water, if any. So where the calculator comes in is to come up with what we're going to need pre-plant in the form of organic fertilizer and crediting the nitrogen from cover crops. Two additional steps I want to mention that won't be the feature today is that we very much believe that the calculator is a screening tool, kind of a first order decision tool, and that really the way that you get better precision in your nitrogen management is to do some in-season soil nitrate monitoring. And this is particularly important in systems where we're building up organic matter, and with that we can build up organic matter too much and have too much nitrate that just mineralizes from pre-existing soil organic matter. So it is important to monitor. And then, of course, your monitoring should inform the next year's plan. So I wanted to review briefly what mineralization is. So it's a good word in terms of describing the process. So mineralization is the process of turning organic nitrogen into mineral nitrogen or inorganic nitrogen. So in soils, the slow step is going from organic to ammonium, and a much more rapid step mediated by microbes is the conversion from ammonium to nitrate. So when we talk about monitoring nitrate, that's kind of where the after mineralization nitrate will accumulate, and we can use that as a tool to see whether we have enough mineralization or not. Okay, so wanted to talk a little bit about organic matter stability and how it relates to how we've set up the calculator. So plant materials and other inputs, they have organic nitrogen that's present in different forms. So if you want to think of it this way, the sugars and proteins are kind of the guts of plant cells, and the cellulose, hemicellulose, and lignin are in the cell membranes and cell walls. So most of the nitrogen we get from inputs that's a high amount isn't a material that's high in protein or high in nitrogen, and this decomposes rather quickly. So if you look at kind of a progression from green leafy material down to soil organic matter, you can see that compost is what we get after some decomposition has happened. So that's the reason why when you put compost into soil, it's not really a fertilizer as much as a soil builder. Depends on application rate, but as I'll repeat several times here, compost is not really an organic fertilizer. So the materials that give us the most nitrogen are those that decompose rapidly in the soil, not those that are stabilized like compost. I wanted to mention this, that the calculator just talks about year one. If you're on a real organic farm, you're following year after year with some kind of management to supply nitrogen. So what can happen is both a good thing and a bad thing. That is that every year that you manage organically, you tend to build up nitrogen in the soil. And I'm trying to show that here in a different sort of way. So in year one, here's the part that's plant available, and then here's the part that carries over to year two. So in year two, we have what's available now, plus some of that we applied last year. And then year three, we've got the same thing, plus this, plus this. So this is the buildup process, and this is why we have some farms that, unfortunately, they've done such a good job of building up nitrogen that they now have too much nitrogen just based on mineralization without any new inputs. So this is kind of a progression in time that I want you to get your head around. So in a typical system managed conventionally, we have organic matter that mineralizes every year, and we supply the rest with urea or some other commercial nitrogen fertilizer. When we go to organic, we have basically three categories of material that are in the calculator. We have compost, cover crops, and organic fertilizers. The problem we see sometimes is that this recipe that works in year two keeps getting reproduced. And as I mentioned, the background soil organic matter is increasing and you're getting more nitrogen from that. So over time, compost is a good builder at the start, but you can build up things too much. So the goal should be to get to a system that has higher background soil organic matter. That's good, but not too much, so that the summer crop, your vegetable crop, can actually utilize the nitrogen from your winter legume cover crop. Down here is where you don't want to be. That's where your soil organic matter is producing a lot of plant available nitrogen at times that your crop is not able to utilize it. Okay, so I want to talk about the calculator and explain to you how simple the assumptions are, but how powerful they are. Our first assumption is that total nitrogen as a percentage of dry weight can be used as a predictor of plant available nitrogen that is released by mineralization. So as I mentioned before, the nitrogen mineralization amount and the rate is controlled largely by what's in the organic input. It's relative amount of protein and fiber, lignin, and so forth. And so in fresh materials, carbon is always about 40%. So really, when we talk about carbon-nitrogen ratios, and we're talking about a fresh plant material or a fresh manure, something that hasn't been composted, really carbon becomes irrelevant and we can just talk about nitrogen. So the reason why we did that was not because we hate carbon-nitrogen ratios necessarily, but just that our producers, they can get a total nitrogen analysis easily on materials that they're bringing onto the farm. but they cannot readily get a carbon-nitrogen ratio from most suppliers. Okay, so we're putting in to the spreadsheet how much of a material and what its analysis is, and the calculator is providing an estimate of the plant available nitrogen at 4 and 10 week time steps. And we often refer to 10 week as full season, and you'll see why in a minute. This is a front-end loaded process that most of the nitrogen comes out rather rapidly in the first 4 weeks. And after that, the remainder of the season, it leaks out slowly, but it's not, most of the action is in the short term. So to use the calculator, you have to distinguish whether you've got organic fertilizer. So the difference is whether it's been stabilized by composting. If it hasn't been stabilized, then it's a fresh material. Cover crops came along after we did the original calculators, and there's a little bit different process there, so they're separate in the calculator estimates. So here's one of the pages in our calculator spreadsheet. Your different sources of nitrogen over here, and this is what is calculated on where the calculation happens in terms of how much nitrogen is released. So the goal here is to look at these materials, get a cost of what you need to pay to obtain these materials, and how much plant available nitrogen results. So to find this, here's the link on the website. It's a free download. You're asked a few questions just for our record-keeping purposes. But the units are English, so that's good if you're in the United States. More of a problem if you're international. Okay, so I want to spend most of my time today talking to you about how we know these predictions are any good or not. What is the basis for putting your faith in these calculator predictions? So the research we did to begin our interest in this topic was published as is shown here, and this work actually predated the calculator. We weren't thinking calculator. Our interface with our local folks stimulated us to build the calculator. So in this research, we looked at these materials, and what they all have in common is that these are materials that are solid materials, and they're dominated by the organic form of nitrogen. And they vary in terms of stability. We have broiler litter and dairy solids and specialty products that are fitting the definition we use in the calculator of fresh materials, and then we had compost that were not. So the take home on the research was, one of them was that we had an excellent relationship between incubating samples of the amendment plus soil in the lab and the performance in terms of plant available nitrogen for sweet corn in the field. So this describes a perfect correlation between what happened in the lab and what happened in the field. And you can see there's some spread, but in general, this gave us confidence that doing something as simple as incubating our amendment plus soil in the laboratory could give us pretty good insight into the availability in the field. So I want to kind of talk about how decomposition relates to nitrogen availability for several different amendments. So one that is probably the most used in organic is poultry litter, broiler litter. And so this is a material that gives a lot of nitrogen and it decomposes fast. So it's got a low carbon nitrogen ratio, a high total nitrogen ratio, high amount of total nitrogen. And so decomposition is almost equal to mineralization or plant available nitrogen. You can see that they are of the same magnitude and they happen about the same time. So that's one kind of material. This would also be the case for a lot of your specialty products that have high total nitrogen levels. Here's another case where we're looking at separated dairy solids versus composted dairy solids. We actually had solids that came from the same dairy, composted some of them, didn't compost others, and we compared the performance in the lab and the field. So as far as decomposition went, composting really reduces decomposition in soil. We expect that. You notice that the compost actually has a higher dry weight percentage of nitrogen and a lower carbon nitrogen ratio. We also expect that because essentially composting is removing carbon as carbon dioxide, so you expect that C to N goes down and total N goes up. So what's the advantage of composting in this situation? Well, mainly what it does is it avoids immobilization of nitrogen after application. You can see that where you have a high C to N material that's decomposing fast, that about a month after application, you've immobilized nitrogen rather than mineralized it, and that never really recovers during the first cropping season. So that wouldn't be a good fertilizer where you need available nitrogen. The compost doesn't immobilize as much. You get positive nitrogen, but not very much. Okay, so how do specialty products compare to compost? Well, compost, won't give you all the details, but here's the typical kind of decomposition, 10–20% of the total organic matter in the soil over 70 days. And here's the decomposition rate for these specialty products. So specialty products, they decompose extremely rapidly. They have high nitrogen and low carbon nitrogen ratios. So these pretty much perform like your broiler litter, the first one I showed, that decomposition happens quickly and nitrogen release happens quickly. Compost in general, they stay above zero, but you're not getting a lot of nitrogen release there. So if we look at all this data and we plot the concentration of nitrogen in the organic fertilizer versus how much is released, the plant available portion, we get these data points, and we decided that rather than try to be too fancy with regression, we just drew a line like is shown here to describe the typical response. And then when we got to 6%, it seemed that things kind of leveled off. So we represented that as everything is the same percentage of total nitrogen release after your organic fertilizer has more than 6% nitrogen. So you can see we didn't have very many data points up here. So we did some additional work. This shows you that here's the difference between 4 weeks and 10 weeks, that you get a little bit more nitrogen with time, but the difference is small relative to what happens during the first 4 weeks. So these are the equations that are built into the calculator. What you're doing when you use the calculator is you're plugging in this value and it's predicting what is the plant available over here. Okay, so to look at more of these things with high nitrogen, we did some incubations in the lab with a lot of different materials. What we found was that our calculator did a pretty good job of predicting what was available from these materials in our 28-day lab incubation. So what I've shown you so far is that just the organic fertilizer and the results after 4 and 10 weeks. I'm going to mention compost here, but I don't have anything very exciting to tell you. So the way that it's handled in the calculator is just it looks at the total nitrogen content. If it's it's assuming you get nothing in the way of nitrogen in the first 4 weeks and 5% of the total N for the year. If you have a higher concentration of nitrogen, it estimates 5% for 4 weeks, 10% for 10 weeks. I'm not very proud of these numbers, and that's because total N doesn't work as well for compost as it does for fresh materials. And that's because a lot of composts will have soil mixed into them. So they might, that throws off the total nitrogen as an indicator of plant available. Also, the best way actually to look at compost is to actually get an analysis and determine how much inorganic nitrogen is there in the compost before you apply it, because we don't see much happening after you apply it during the first year. So that's the best way. This is an estimate, and it's in the calculator because we have a lot of people that assume that compost gives you more nitrogen than fresh materials, and this is to show that, in fact, composting turns a potential fertilizer material sometimes into a soil builder. So compost is not what you want if you want plant available nitrogen in a hurry. It's a great soil builder for the long term. Okay, so following the work on organic fertilizers and compost, cover crops became more of an emphasis. So we looked at those with our lab incubations, and I wanted to kind of use that as an example of how this could be done for other organic materials that we haven't thought about yet. So on the cover crops, we obtained a biomass sample from the field. We incubated fresh samples in the lab, tried to make the chop them up so they would mix with the soil better. But we didn't do any other preparation, and that's because we found out in some preliminary work that drying and grinding plant samples, as is done in a lot of research studies, it will actually lower the plant available content, how much mineralization happens. I think there could be a variety of reasons for it, but it's fairly consistent that we get more consistent correlation between a lab incubation and what happens in the field if we use a fresh sample. So we tend to use a lot of cover crop residue in a lot of soil for our incubations and try to accommodate the variability that you see here in the samples. So the method is basically the cutting up cover crop, mixing it with soil, putting it in a bag, letting it sit there for 4 and 10 weeks, and measuring the nitrogen that is produced, the nitrate nitrogen. We've also measured ammonium, but we don't find much ammonium, so I'm just mentioning the nitrate. We've got a little straw in here to try and keep the bag open so that it doesn't go anaerobic inside. For the 10-week, we add some water midway through to keep things from getting too dry. And we always compare the amended soil to a control soil that has no cover crop. So here's some results that we had for a trial that had, we were looking at mixtures of common vetch and a non-vetch material called Facelia. These are cover crops. So the take home here is that for cover crops, what the calculator does is it uses an equation that was published by Vigil and Kissel in the Soil Science Society of America journal, which is this red line. So these are our experimental results from the lab with the little bags, and it shows that in this particular case that there is less nitrogen than the calculator predicted at 4 weeks, and at 10 weeks things were pretty close to the predicted amount. Okay, so to review kind of the principles of the organic fertilizer calculator and why we think it's pretty reliable. So for fresh organic inputs, plant available nitrogen release is controlled by carbon-nitrogen ratio and decomposition rate. And total nitrogen makes a good index of the C to N ratio, so that's a reliable index for a fresh material. Things happen pretty rapidly, so we don't need tremendous precision on the mineralization rate. It happens so fast for most of these materials that compared to the time that elapses between a pre-plant application and when a crop really needs it, there's plenty of time generally. And we have data on compost to show that they're a very expensive source of plant available nitrogen, and they should be used primarily for soil building. And I wanted to mention that in my experience, it's easy to get in the habit and do the same thing every year. So recommend some soil nitrate monitoring during the season to see how much nitrate is being produced from the sum of what is produced from soil organic matter plus your cover crop plus compost and organic fertilizer if you use those. Because basically if you have too much, you're spending too much money and the nitrate is ending up leaching over the winter in our environment. Okay, so that's what I have to say about the details of the calculator. It's available for free download from this website, and I thank you for your time and your attention.